So 2.6 rules for multiplication. Before we talk about all these rules, let's talk about some of these properties first a little bit. I think a lot of you already know this. How many people know that if I multiply, we sort of talked about this before actually. Yeah. If I multiply a times 1, how many people knew that you get 1? Raise your hand. Good, okay. Of course, I could also do what? Using the commutative property of multiplication, instead of writing a times 1, I could write 1 times a is a. So let's see if you remember, we talked about this when we're talking about something with addition. When you multiply a number by 1, you get yourself back. Do you guys remember that? Remember the one where for addition, what do you have to do for addition to get yourself back? Yeah. Add 0. What was that called? Yes. Good. That was called the identity property of addition, right? You get yourself back. Anybody want to guess? We sort of talked about this already. Anybody want to guess what this is called? Good. A lot of you. Okay. How about... Alright, how about Samuel? Park. How many people agree with him? He said identity property of multiplication. How many people? Anybody have a different answer? No? Okay, he's correct. You are all correct. Okay, so it is called the identity property of addition. We talked about this. I mean, not addition, sorry. Identity property of multiplication. Right? Sort of like the identity property of addition, right? Very similar, right? For addition, you add 0 to it, you get yourself back. For multiplication, of course, you got to multiply by 1. Right? Easy enough? Okay, so you have to know this property. Do you think you may see this on the test? Yeah. Okay. All right. Next. How many people knew that if you were to multiply a number by 0, what does it always equal to, guys? 0. Okay, good. All right, and so this one has a name. It's called... Does anybody know? Aiden? You can't remember? I'll give you a hint. It starts with multiplicative property of... What do we multiplying?
0.
So guess what it's called? It's called the... Tawar, what do you think? You got it. It is called the multiplicative property of 0. Write that down. It sort of makes sense, right? Because, you know, you multiply something by 0. So what sort of property do you have when you multiply something with 0? You get 0, right? That's why the name is called the multiplicative property of 0. Okay? I'll move it up for you. Okay? There you are. Anybody need more time? We good? Okay, next property. Okay. What happens if you multiply a number by -1? What do you get? Like, for example, if you multiply a times -1, what do you get? Spencer? Yeah, the opposite of that number, right? You get -a, don't you? And so the other way around. So, for example, if you were to multiply a with -a, you get -a. Or, of course, -1 times a is still you get -a, right? Anybody want to guess what this is called? Let me give you a hint. It is very similar to the second property we just talked about. So instead of multiplicative property of 0, guess what this is called? This is still kind of similar, right? Camila, what do you think? Oh, opposite, almost. Actually, this time we just said 0, right? What are we multiplying? By -1. So guess what? It's multiplicative property of? Exactly, -1. Okay, guys? So if you remember the second one, you know the third one, right? They're very similar. Second property is just basically if you multiply something by 0, you know, it's called the multiplicative property of 0. You get 0. If you multiply something by -1, you know, you get the opposite of the number. It's called the multiplicative property of -1. Please do not get this confused with property of opposite, because you guys see that you get opposite of the number, right? What does property of opposite tell us? Anybody remember? One person? Two? Livy, what did it say?
If you add a number and its opposite of it.
Exactly. So that one tells you if you have a plus what? -a, you get 0. Is that same as this? Multiplicative property of 0. I mean, -1. No, they're very different. This time, you're multiplying by -1 and get the opposite of number. The other one, the property of opposite, is where you're adding two numbers that are opposite of each other, then you get 0. Does that make sense, guys? So please do not get those two things confused. Yes? You need to know which one's which, okay? Does that make sense? All right. Let's move on then to the fourth property. Okay, so let me move down a little bit. Hold on. So if I give you the name for this, what do you get when you multiply negative a times b, guys? Yeah, Livy? Negative ab, very good. What do you get? So these are all same problem. Now, what do you get if you multiply instead of a negative a times b? What if you have a times negative b? What do we get here in this case? How about Eunice? What do we get here? Negative ab again. Exactly right, Eunice. And then, what if they're both negative? Like negative a times negative b. What do you get there? Lindsay? It'll just be AB. And even though we know this already, there's a name for it. It's called the property of opposites in products. Okay. So if you ever see that step on one of those problems where it asks you to justify each step, you will write down property of opposites in product. This one is not as popular as the other one, but it's good to know what it's called. Okay. The first three properties that we learned, those are pretty well used. Okay, we use that a lot. This one seems to, we don't really use this much. Yes?
How many properties are we going to learn?
Couple more. But for chapter 2, I believe this is it, I think. Okay, so, yeah. For chapter 2 only, yeah. But we've actually talked about, and then we don't really talk about that many properties afterwards. In the beginning, we tell you all these properties first. But you have to know them throughout the whole semester. Yeah, any question? Does that make sense? May I move on? All right. It actually goes along with what we just talked about, rules for multiplication. Okay, so that property that we just talked about is sort of similar to this, but not 100% the same. So first rule. Let me ask you this. What happens if you multiply positive times positive, guys? You get? Positive. What about if you multiply negative times negative?
Positive.
It's still positive, right? So the way we say this here is this. This is how we say it. We say, notice when they have same sign, right? If two numbers have same sign, in other words, they could both be positive, like this, or they could both be negative. The product is going to be positive. That's the first rule for multiplication. So if two numbers have same sign, meaning they're both positive or both negative, their product is positive. That's first rule for multiplication. So go ahead and write it down. You all know this, right? This is something that's not new, right? You should all know this. Okay. What if, then, what's the other case? Do they always have to have same sign when you multiply two numbers? Of course not. So anybody want to guess what it's going to say next? Yes, how about two people? Eric, what do you think, sir?
If two numbers have different sign, then it's negative.
That's exactly right. This is exactly what I'm going to write down. So this is the second part of that first rule. If two numbers then have opposite sign, because that's the other possibility, their product is, of course, negative. For example, negative 2 times 3 is negative 6, or 2 times negative 3 is negative 6. Right? So nothing new. We'll just, this is the rule for multiplication. Okay, so I'll wait. Okay, so that was the first part of the rules. It had two parts, right? First part of the rule for multiplication. Second part is, let me ask you this. If I have a bunch of negative numbers, okay, and I happen to have 1 million of them, okay, I have 1 million number of negative numbers, and Chris, I multiply them all, okay, what do you think the end product would have? Which sign would it have? Would it be positive or negative? If I have 1 million negative numbers and I multiply all of them, it would be positive, wouldn't it?
Yeah.
What if I have 1,000,001 negative number? Then it will come out to be negative. So that's our second rule. The product of even number of negative number is, guess what would this be, guys? What would the answer be? Positive, right? Okay. What if I have odd numbers?
Negative.
Then it will come out to be negative, exactly. So just like the first part of the rule, it had two parts, this one too. So this, now how come we don't talk about all positive numbers? Why do we only talk about even number of negative numbers and odd numbers of negative numbers? How come we don't talk about positive numbers? Samuel?
Because no matter what positive multiplies by positive.
Exactly. No matter what, positive times positive is always positive. So we don't even talk about that. But if you have negative numbers, right, it depends, right? If you have even number of them, it'll be positive. You could think of it as like pairing them up, right? If you pair negative times negative, that's positive, right? So if you have even number of them, it's going to be all positive. Whereas if you were to pair them up and you have odd number of negative numbers, guess what? Everything will be paired up and be positive, but then you would have one negative at the end. So the whole thing will be negative, right? Does that make sense? You get what I'm trying to say? So you can think about sort of pairing them up, just like the first rule. Because negative times negative is positive, right? But positive times negative is negative, right? Okay? Nothing new. Any question? Good. Write it down. Okay. So example 1 then. Take a look at this example. Very simple. I'm going to ask you to simplify this expression. 6x times negative 3y. By the way, what do you think the end result will be? Do you think the end result will be positive or negative? How many people think it's positive? Raise your hand. No one? Okay, how many people think it's going to be negative? Good. Why would it be negative? Matthew? Right. The first expression is positive, the other is negative. What's positive times negative, guys? Negative. Okay, I'm going to kind of separate them like this. Is that okay? And then gather the numbers together using the commutative property of multiplication, right? Change in order which I multiply. And of course, what is 6 times negative 3, class?
Negative 8.
Good. And what's x times y?
X, Y.
xy. Okay, so there you go. Easy enough. Okay. So, very simple. Okay, let's move on to the next one. Yes, I do want you to write out these steps where you gather the numbers together, because you could change them in different order, right? You could use the commutative property of multiplication to rewrite it this way. So yeah, I want to see that work. Very good, thank you. Now let's move on to example 2, okay? Example 2 is a little bit silly because 6p plus negative 11p. Don't we already know what the answer is? What's the answer, class?
Negative 5.
Negative 5p, right? But since we talked about distributive property yesterday, especially going backwards and so forth, right? And since we're talking about rules for multiplication, I want you to show that work. Okay, so what would the work be? How would you show that this is negative 5p? What would you do here? One person see it? Two? Using the distributive property as we learned last time. Aiden, what do you think, sir? How can I use distributive property to show that this actually becomes negative 5p?
6 plus negative 11 times p.
That's exactly what I'm looking for. Does that make sense? I wrote p first. Is that okay? And then, of course, 6 plus negative 11 gives you negative 5. And here, now, this is where the rules for multiplication works. P times negative 5, right? What's p times negative 5? Positive times negative is negative, so negative 5p. Exactly. Okay? Easy enough? So don't just write negative 5p. I want to see these sort of properties that we learned, okay? Since we're talking about them. Huh? Yeah, in your homework. Yeah. Yep. Exactly. That's the work I want to see, guys. Yeah, I know that a lot of you know this as negative 5p, but can you show these algebraic steps behind it? That's the whole point of this class, okay? That's why it's called algebra, by the way. Okay. Yeah, question?
If you don't show steps on the test,
You're right. On the test, it depends on what I ask. So we'll talk about that later. But on the homework, at least for homework, can you do this? Okay, great. Let's move on to the next example. Here's example 3. Negative 6 times, in parentheses, a minus 5b. Okay. By the way, how many subtraction do you see? How many subtraction symbols? Show me with your hand. How many? Okay, a lot of you. 100% participation. And some of you are still writing. Sorry, but once you're done writing, can you? Yes, very good. There's only one. What about this first symbol here? Is that a subtraction sign or is that negative 6? That's negative 6. So let's just change this in addition, right? Okay, so how do I change this to addition? How about Eric?
A plus negative 5b.
That's correct. Now we're ready to distribute. Okay, so I would like every time you have expression, I would like you to change all the subtractions as in addition. Then multiply it out. So Eugene, tell me what to write here, sir.
Negative 6a plus 30.
Good. You're using the rules for multiplication, negative times positive, you get negative 6b, right? Plus negative times negative, you get positive 30, right? So that's where we're using the rules for multiplication there, right? But a lot of you already knew that, most of you. Okay? Does that make sense? Could we add these together? No, we cannot. We cannot use, right? They're not like terms. In other words, you don't see any, you cannot distribute backwards, right? And then do it. Because we don't have any common factor. Actually, you do. If you do that, then you go back to what you had before, right? Negative 6 is common in both. Isn't that right? Anyway, so we multiply this out. Any question? May I go to example 4? So we simplified that. That's good. Okay. So this is one of those class questions that people, if you're not careful, mess up. And I like this question. Okay, first of all, write it down. 5 minus, oh, I'm sorry. Oh, you can't see it though. Hey, 5 minus, in parentheses, 2r minus 9. Like I said, this is one of those classic questions that if you're not careful and you're just trying to rush through and do it, get it wrong. So, anybody see what kind of mistakes that people can make with this sort of question? What kind of make do you think people... Oh, Kevin, what do you think, sir?
They would do 5 minus 3 first.
Isn't that what we do first?
No.
That's right. If you do that, that's how you get it wrong. But we all know how to do 5 minus 3. It's so easy. It's right there. It's so tempting to just go 5 minus... No? Why can't we do that, Kevin?
Because it would change what's in the parentheses.
Yes. Yeah. Anybody want to say... Tawar, what do you think?
Because like the order of operation.
Order of operation. Why does he say the order of operation here? Lilette? Because of parentheses? What do you mean?
Because you have to multiply.
That's right. You have to... There's the multiplication here first that you have to do. Not subtraction. Do you see the multiplication? I don't see any multiplication. Where's the multiplication at? Yeah. When you have 3, right, in parentheses with something here, there is a multiplication symbol right here. Isn't that right? Does that make sense? So you have to do that first. Please do not do 5 minus 3 and write 2. Okay. If you do that, then you get it wrong. Does that make sense? All right. So then, how many subtraction symbols do you see here? Raise your hand. Show me with your finger. How many subtraction symbols do you see? Okay. Good. I want 100% participation. Some of you are not. What do you think, sir? Joseph, what do you think? How many? 1? Which one is the subtraction symbol? One between, in the parentheses, right? What about this one right here? Is that negative sign? Not quite, because this does really mean 5 minus 3 times this whole thing. So this one is actually a subtraction sign. If I didn't have this 5, then you could say, oh, that's the negative 3, right? But this is 5 minus 3. This does not mean 5 times negative 3, does it? You see what I'm talking about, Joseph? So you're going to change, you have to change all the subtraction signs into addition. Can you help me how to do that? What would 5 minus 3 be, Joseph, if I change it to addition? Yeah. 5 plus? Yeah. So you see how that's a subtraction symbol? What about 2r minus 9? What would that be? Exactly. Do you see why there are 2 subtraction signs there, Joseph? Yes? Any question? Clear? Okay. Go ahead and finish this up. I'll wait for you guys. Now, you have to distribute this negative 3, right? You guys done already? Yeah, go ahead. Does that make sense? I'll wait. Okay, good. I hear a lot of people saying, oh, yeah, that's right. Sorry, that's wrong. Okay, good. As you discuss this with your groups, who could tell me? How many? Okay, how about 1, 2, 3, 4? How many people could tell me the actual answer? What do we write next? Let's just do this step by step. Who haven't I called it? Jason, what do you think, sir?
Alright.
What's my next step
You
here?
write 5 plus
Right.
negative 6r
Uh-huh.
plus 27.
Exactly. Did you all get this? How many people stop here? Is this right? No. You have 5 and what? 27 you could add those together to simplify. This is not fully simplified here. Okay, so you don't stop here. You need to add them together, right? So Carolyn, what do you think? What's the answer then?
I got 32 minus 6r.
Yeah, 32 minus 6r. Turns out normally, okay, so I actually reordered these terms, right? Because addition is you have community property of addition. So yeah, but turns out you want to write the terms with variable first and then a number. Okay, but it's not wrong to write it that way. But this is the normal way of writing. Okay, called standard form. Does this make sense? How many people got this? Raise your hand. Okay, good. Good. If you didn't, do you see a mistake? Okay. Did your group members tell you how to do that? Okay, may I move on then? Does this make sense? Good. Let's move on to the next. Here's example 5. It's sort of similar to the one that we just did. I have 1 minus in bracket -4 times in parentheses x minus y. Okay. So, in order to simplify this expression, by the way, as you write this down, I want you to think about and show me with your fingers how many subtractions we have in this example 5. How many subtraction symbols do you see in this example? Okay, some of you have 1. That would not be correct. There are 2. Most of you have 2. There are 2. Eunice, why are there 2? Which ones do you see here? Yeah, there's one x minus y inside the parentheses. Where's the other one? One after the 1, exactly. There's one right here. Do you see that, guys? What about this negative? What about this symbol in front of 4? Joseph, what do you think? Is this -4? Is that a subtraction, or does it belong to the 4 only? Is this a subtraction symbol or -4? Right here, 1 next to 4, left of 4. Yeah, it just means -4. It's not subtraction, right? Does that make sense? Do you all see this, guys? Yeah? Bella, can you help me how to rewrite this as an addition, by the way? But Bella, I have a question. This is 1 minus, right? This is a subtraction symbol, right? I don't see any number here. So how do I change the how do I write the opposite of that number? What is really there? Exactly right. So do you guys see that there's really an invisible 1 there? Right? And now do you see how you could rewrite this as an addition? Who could help me how to do that? How about Carly? Can you show me how to write this as an addition? There are 2 subtraction symbols, right? One right here and another one right here. So it'll be 1 plus what? Because of that invisible 1, it'll be? Exactly. 1 plus -1 times. You could kind of imagine it this way, right? If you have 1 minus 1, what is that as an addition? 1 plus? -1, isn't that right? Would you not agree? Yeah, it's the same way. So it'll be 1 plus -1, right? Right? Times -4 times x plus y becomes x plus? X minus y, I mean. X minus y becomes what? X plus? As you write as an addition. X plus y? No. When you have a subtraction, it means you add the opposite, right? So x, yeah, it becomes x plus. You said it, you're right. Yeah, so you see how we have x minus y? How would you rewrite this as an addition using the definition of subtraction? It'll be, subtracting is adding the opposite, right? So x minus y is same as x plus. Yeah, negative x. Negative y. Would you not agree? Isn't that what we get? Do you guys see how we could change all the subtractions as an addition? And of course, do you know what to do next? What should we do next here? One person see it? Do we still have to follow the order of operation? Yes, always, okay? Aaron, what do you think? Distribute what? There are many things to distribute. Negative what? Yeah, -4 to x plus -y. Why do you want to distribute -4 first, not -1? Michael? Because it's in the parentheses. You gotta follow the order of operation. Exactly right. By the way, can I instead of distributing this -4 first, can I do 1 plus -1 here at this point?
No.
No, that will be very, very wrong. Okay, because you're not then following the order of operation. Because if you did, the whole thing will be 0, which is not true. Does that make sense? So I want you to then distribute -4 first, and then distribute -1 afterwards. Go ahead, everybody try. I'll give you time. So who could tell me what I get when I distribute -4? How about, who haven't I called today? I haven't called, Mimi. What do you think? When I distribute -4, tell me what I get inside of this bracket.
-4 x plus 4.
Exactly right. Very good. Everybody okay? Look what happens as you distribute. What happened to the parentheses? As you distribute, it goes away. Very good. And guess what's going to happen to this bracket as I distribute this -1, class? It'll also go away. Sammy, tell me what I get when I distribute this -1. 1 plus. What's -1 times -4? X.
4x.
Exactly. So tell me what to write. 1 plus. 1 plus 4x minus 4y. I like to keep everything as addition still. So it'll be 1 plus 4x plus what? Exactly. That's how I don't, I want things in addition, okay? I know that it still means 4x minus 4y, but yeah, I like to. Okay, could I gather my like term or simplify further? No, you're done. Okay, so what's the best way to write this? Remember I told you to write the one with variables first? But here we have two of the terms that have variable. Which one should we write first? Claire?
-4y.
You think I should write -4y first? You could, but actually if you write this in standard form, you want to write this in alphabetical order. So which one comes first, x or y? So
4x.
yeah, 4x and 4. Yeah. So it'll be a little bit different once we have exponents and so forth, but they both have exponent as 1. So it'll be 4x plus minus 4y plus 1. Any question? Is this easy? Yes.
Whenever you have like plus -4y, you can make it -4y.
Sure. So at the very end, when you write the answer, I want you to just use subtraction, using the definition of subtraction backwards. But when we're simplifying or doing things like this, it's good to change everything to addition. But at the very end, I want you to write as simple as possible. Okay? Any other question? Does that make sense? All right, let's move on. So we're going to do a C for you right now for these two questions. Hold on, let me give you the papers. Give me a sec. So I want you to now go ahead and do C for you for number 6. It's from section 2.6. And then C for you number 7, 2.5. Show that 3x plus 7x equals to 10x. Let's see if you remember from last time how to show that 3x plus 7x is 10x. We all know it's 10x. Do you know? Can you show this algebraically? Okay. So yeah, go ahead and write these down for number 6 and 7 and do those. Yeah, question?
We haven't done
Today's lesson is 2.6.
Yeah.
Yeah. So, right, if you got all those examples that we did today, you should be able to simplify number 6. Yes? Oh, don't worry about the -8. No, that's how many people got it wrong from last period. Hey, last period, they got 100% on number 7. I'm hoping that you guys would get 100% on this one too. And I'm hoping that a lot more than I'll have, I want to actually get 100% on number 6 too. Because I don't know why people mess that up. Okay, hopefully you guys could do better. Go ahead, everybody try. Here, is this better? Okay, don't worry about those numbers. Go ahead, everybody try. So, number 6. Okay. Give them a half point if they have this. Where they change it to an addition. Is it still frozen? Sorry. Where they change it to an addition. And you got -1 times this. Give them a half point if they have that. Now, of course, when you distribute -1, you get 1 plus 3x plus -4. And then, of course, 1 plus -4 is -3. So give them a half point if they have this step. Now, if they're supposed to go down and write 3x minus 3, if they didn't, still I'll give you full credit. Okay, that's fine. So if they have this step and this step, they get half points each, so you get full credit. But you should really simplify. Question? -3 plus 3x. Oh, okay, I'll still give it to him. But like I said, you should write the one with the variable first. Yeah, that's fine. Yeah, question? Yes, sir?
What if they skip 3x plus -3 and not skip 3x minus 3?
Then you would just, which one did they skip? Which part?
3x plus -3. They would skip 3x minus 3.
That's fine. That's fine. That's still fine. Yes.
What if they're not the answer?
Then, but they have this step. Then they only get half. They only get half. All right. Yes. Okay. Let's go to the last one. This one should have been pretty simple, right? This is distributive property backwards. How do you show that 3x plus 7x is equal to 10x? Well, what's common in both of the terms? Class? X. So isn't this the same as x times 3 plus 7, or you could write 3 plus 7 times x. Isn't that how we get 10x? Because 3 plus 7 is 10. So if they got that, so if they have this step right here, either this one or this one, give them a half. And at the end, of course, you should have 10x and give them a half, so you get full credit.
So
Yeah, question?
What if they just skip x and 10 in parentheses?
Oh, if they skip this one right here,
Yeah.
that's okay. That's okay. But do they have 10x at the end?
Yeah.
That's fine. That's fine. If they skip this one, x times 10, that's fine. Because if you wrote it this way, Claire, they would just go straight to this anyway. Okay, any other question? Okay, raise your hand for the person that graded. Okay, the person that you graded. How many people got this one wrong? Number 6. Oh, okay, one. One. Not you, but the person that you graded got number 6 wrong. 1, 2, 3. Oh, 1, 2, 3. 3. That's it. That's pretty good. That's much better than.
I got it wrong.
Yeah. So. Okay.
I switched the 3 to a 4 for the x.
Oh. But do you know why you did it wrong then?
Yeah.
Okay. Good thing it doesn't count towards your. Yeah.
For number 7.
Yes.
3 plus 7 equals 10, then x times 3 plus 7 equals 10. They like kept an equals 10 on the side, drawing instead of minus.
That's okay. That's okay. They're not supposed to. That's okay. All right. For number 7, how many people got it wrong? Oh, 2 people. 2. Still half is still wrong. All right. Okay, 2 people. That's fine. We'll try. We'll shoot for 100% next time. Okay. Any question? Okay, give it back to the person. Very good. Okay. There you go.